So I got this 2003 MR2 here. Guy had it from 3,000 miles all the way, I think it's got 120,000 on it now. It's in great shape overall, but it has the SMT and currently will not go into any gear. It gives you the flashing green light for neutral. Put it in gear and you get this flashing light on the SMT. It doesn't go anywhere. So after doing some testing, I think this is going to be hopefully an easy fix. So if you take all the panels off and you go underneath and you look at the actuator right here, there are two different sensors. You can see both of the ports there where I've already removed it. And one of these I believe is the clutch position, which is the one to the left. And then the other one I think is one of two sensors for the shift position. And you can see kind of evidence where brake fluid or the SMT fluid has leaked down into this bottom one. It does have a little tiny notch there, but it doesn't seem to do a good job of letting the fluid drain without getting into the sensor itself. And this causes the sensor to fail. So these sensors are no longer available through Toyota New, but you can repair them. So after doing some research online, I was able to get the information on how to diagnose and repair these sensors. So we're going to try that. I'm going to step you guys through the process. Okay, so with the sensors off the car, you will need a 5-volt DC transformer. This one is from some old electronic. I just stripped the ends off of it. I think USB is somewhere like 5.2 volts, or you can string some batteries together, but you will need 5 volts. So I'll just show you here on the multimeter with this plugged in. So it reads just over 5 volts, about 5.1 volts. So we'll unplug this. And there are 3 pins in these sensors. So we're going to be hooking up power, ground, and then measuring the signal. I think it's power, signal, and ground. I'll just double check and post the wiring schematic up here and then get this hooked up. You can then move the sensor along its range. So I have 2 sensors here. This one I've already verified, so I'll show you the reading on it. It's good. This one is, I think, 3 volts right off the start. So I'll show you how to wire these up, and you can test one that does work, and then I'll hook this one up and show you one that doesn't work. Okay, so we have this hooked up. I'm just using some alligator clips. You just want to make sure the pins are separate. This one is going to be power. This one is going to be the ground on the outside, and then the center pin is actually the output. So the way you'll hook your meter up is the 5-volt supply goes here. The ground you'll want to split. One side is going to go to the meter, the other side is going to go to this pin, and then you'll take a measurement off the center pin here. So meter is set to DC. You can see it's at 0 volts, and I'll go ahead and plug this in. And it's still at 0 volts, and that's actually what you want. I think it can have a tolerance of like up to 0.1. I'll post again the little table up here, but you can see as I articulate it, the voltage goes up to about 4 volts, and you don't want to force it. I don't know if it has a positive stop, so this one actually goes all the way to 5 volts. And it seems fairly linear. I don't really have anything set up to do a measurement, but you can see this one functions pretty well. And this one didn't have any evidence that fluid had gotten into it. You know, I'll clean it up, of course, but I'll hook the other one up, and I'll show you what this one does. And again, spring-loaded in the off position, you can see this one is at 0 volts. Okay, so I got the bad one hooked up here. I'm about to plug it in. You can see it's at 0 volts right now. And when I plug this up, immediately goes to 3 volts. And again, it's spring-loaded, so we know that it's at the end here, and it still works. You see scales to 5 volts, but again, it only goes to 3. So my suspicion here is that the transmission is seeing this, and it's at too high of a value, and it goes into some type of limp mode. So again, it should be at 0 volts. Have to go back and look at kind of the diagram for this. I think this means that it's increased resistance, so maybe the brake fluid just adds resistance to it, or the mylar strip is damaged. So we'll take it apart. I'll show you guys how to cut this open. As I've seen, you can do that without doing any damage on this top cap. We're just going to be using a Dremel here with a plastic blade. These things work pretty good and give you some control. So we'll put it in the vise and cut it open, and see what we can do to repair it, and hopefully get that back down to 0 volts. Okay, so what I'm going to do is I'm just going to cut around the top here. The edges are pretty straight here. I'm just going to do a straight cut. I can seal it back up with epoxy pretty easy. And then around this, I think I'm going to do the edge. So I'm going to start with 3 cuts, see if I can pry up, and then go from there. Okay, let's do it a little bit at a time here. I'm going to, let's see. Got some small metal screwdrivers. A couple different picks that we will use. Let's just see if we can pry this up here, get the old plastic out of the way. Okay, it doesn't look like we've quite gone deep enough, so better take it a little bit at a time. So I'm gonna cut that a little bit more here. So this is interesting. I've cut it and you can see it was starting to smoke, and you can actually see where brake fluid is inside this thing and coming out. So pretty confident that is the culprit. Now it's just figuring out how to get this thing open without damaging it. Once I get it apart, you know, I'll be able to show you guys where the electronics are, just so you can know how deep you can go. So I think I'm gonna cut around the outside here next, and then try to pry it up that way, and then maybe come inbound a little bit more there. Again, it looked like it was sealed right where I cut it, but just take our time with it. And again, plastic epoxy can seal this thing up, so no harm, no foul, as long as you don't cut any electronics in it. Okay, let's see. Looks like I'm starting to get to something there, so I don't want to go any deeper. Okay. All right, well, I will say, do not have a lot of room for air there, but I don't think we did any violence to the sensor. I'll get this out of the way. We'll hook it up just to make sure we didn't do any damage here. That it still reads the same voltage, and once we do that, then we'll go through and clean this. But it looks like all of the brushes are still in place. Looks like there's just 2 brushes there. Take this off here so you can get a better view of the inside. See, there's 2 little brushes that just wipe right there. And I'm guessing that fluid has either damaged this mylar strip or just added a layer of resistance. So we're gonna try just cleaning it out first and spraying it with MAF cleaner. You can actually just do that in place here. Dump it out. Get a rag to do that. We'll just clean it and then measure the resistance and see if anything's changed. Okay, so no change in status, unfortunately. So cleaned it, tried the pencil trick. I don't think the pencil trick does anything, so I think that probably just cleans it if anything else. So rubbed it down with alcohol. Pretty confident everything is cleaned out of here at this point. So I did read that this little clip, I think what this does is just a little spring clip that connects the back of the mylar strip to the connector. That this is where moisture gets trapped, and then it kind of bridges it, and then, you know, there's no resistance there, right? So that would kind of indicate what we're seeing. So I'm going to pull that out. So these are from the Metal Earth that makes the little metal bottles, and these are like the best tweezers I found. You can really pinch the crap out of stuff with them. So I'm just pinching this, just gently pulling it out. And you can see it's literally just a metal spring clip. It looks symmetrical, so you don't really have to pay much attention to how it came out. So what I did is I went with a razor blade around the back side of this just to make sure that the plastic wasn't holding it, because again, you don't want to pull on this too tight. You can see I've already been able to work it loose. So what I will do is just use tweezers gently on all sides, lightly pull up on the resistor strip, and then careful with the brushes, getting it back. I'll have to be careful with that. And now we got the strip out. This whole little thing. So it does the resistance, and you can see right there, that is super gross from brake fluid. So I'm gonna start with I think Q-tips and MAF cleaner, so electronics cleaner. You can also use a rubber pencil eraser to clean traces. We're gonna clean that the best we can, put it back together, and hope that we get a good resistance. So I think what we're seeing right here is actually this, where it's bridged right there. which would explain the low resistance and giving us, you know, high voltage when we should have a low voltage. But we'll see what we can do to clean this up and take some tests on it, and then get another reading. Okay, guys, I'm not gonna lie, I was pretty skeptical and thought this thing was gonna be trashed, but I cleaned the strip again, just with alcohol and a Q-tip. While that thing was out, I sprayed the whole thing out with brake cleaner just to get rid of any of the brake fluid. Washed it out with alcohol, blew it out with compressed air, put it back together, and lo and behold, look at that, 0 volts, 5 volts, 0 volts. So sure enough, it really was just a little bit of corrosion on the back of the Mylar strip and the little clip right there. So getting it back in, sorry I didn't get a video of that, but you just kind of start here on this end because it has a positive stop, right? Work your way back in, and then I kind of just tilted it down, and you want to be careful with the little brushes. So what I did is I just kind of twisted this by hand as I was feeding it in, and allowed these things to kind of just ramp back up on there without doing any violence, and all good. So I think I will seal this up. I'm probably going to use a little bit of plastic epoxy. Going to clean this up good with alcohol, get rid of the little brake fluid, seal it up, and see if that fixes our SMT issues. Alright guys, so I got the new sensors in. Tried to go through the procedure where you just leave the door open and it would recalibrate. That didn't work. I did have to get Toyota TechStream, hook it up, have it go through the part replacement reset. It's like one of 2 options you can pick. Transmission went through all of the noises and recalibrated, and happy to report it is now driving perfectly. So you can see no more flashing light, goes right to reverse. Clutch engages really nicely. Going into first gear. And even up my crazy driveway here, no issues with the clutch. I did drive it around and go through the procedure where you just kind of you go from first to third gear, and then you downshift once. I'll post a link to that. Definitely helped with the clutch engagement, and now it's driving pretty great. So I think before I start the swap on this, I'll just drive it around and enjoy it, and see what else I can learn on this SMT. So yeah, if you have one of these that's giving you issues, check those sensors since you can't get them anymore. It was not too bad to repair those, and you can keep one of these things running rather than have to do a manual swap or spend a couple $100s on a used sensor that you don't know is going to be any better than this. So hopefully this helped. If you have any questions, leave me a comment, and I appreciate it.